In this video, we're going to do an overview of statistics. Let's first start with some of the general terms in statistics. First, when we're dealing with statistics, we're often looking at data. And data is information that we can get from a whole different variety of sources, such as observations, measurements, responses, and counts. For example, if we look at this problem, they went through and collected data from spinal cord injuries to minors that came from vehicle accidents. And they were looking to see whether or not wearing a seatbelt had any influence on that. Now, statistics is actually the science of doing the collection, but also the organizing, analyzing, and interpreting of all the data you collect to make decisions. When we talk about doing statistics, we talk about whether we're dealing them to the population or to the sample. And the population is all the outcomes, responses, measurements that are of interest. And that can be population can be an entire group of people, say like the United States, or it could be a smaller group, something like a college. And then from there, from our population, we determine what will be our sample, because a sample represents a subset of the population. So if our population was the United States and all the adults in the United States, a sample would be maybe 1,500 members that we would survey. If we're talking about the college being a population, maybe we randomly sampled 25 students as part of our study that we would be doing. So let's look at this problem. It says in a recent survey, 1,708 adults in the United States were asked if they think global warming is a problem and requires action. 939 said yes, and they want to know what's the population, what's the sample, and describe the data. So our population in this case would be adults in the United States, because that's the larger group that this sample was pulled from. And the sample then are those 1,708 adults that were asked this question. They're the ones that participate in the survey. Now if we look, our data then is how they responded, because that's the information that we're getting from them. And from the data, we know that 939 said yes and 769 said no, because those two have to add up to 1,708. Now also we can talk about parameters and statistic. A parameter is a characteristic describing something about the population, whereas a statistic is a number that describes a characteristic of the sample. And so you have to pay attention to those words, statistic versus the generalized statistics. Okay? A parameter is something like a population mean, a population variance, and we'll get into those types of terms down the road. So let's look at some examples and tell whether or not we're talking about a parameter or a statistic. So in a recent survey of a sample of MBAs report that their average salary for an MBA is more than $82,000. Well, the key word you should recognize here is this word sample. As soon as you know you're dealing with a sample, the information you have, in this case an average salary, is representing a statistic. In this case, before school began, a principal surveyed all 37 teachers and found that 12 had attended college during the summer course. Well, the principal surveyed all the teachers of the school. In this case, our population is the entire school number of teachers. So that is a parameter, because in this case they actually dealt with the entire population. And the last thing here we're going to talk about is descriptive statistics versus inferential statistics. If I'm talking about descriptive statistics, that's actually the information that we gather. The organization, the summary, and the display of the data. Whereas our inferential statistics, we're going to take that data and try to draw conclusions that we could make about the entire population. So let's look at this example. So we've got a large study of men, and they followed them for 18 years, and what they found is that 70% of unmarried men were alive at age 65, whereas 90% were alive at age 65 of those that were married. Now the thing that's important here is the fact that we first need to talk about what's descriptive and what's inferential. Our descriptive is going to be all the information we have about the two different groups. We know 70% of unmarried men were alive at 65, 90% of married men were alive at 65. So that's our first important part. Now, when we talk about inferential statistics, we want to take what we know about our data and then say something that is going to help us know about the population. We're not going to try to guess why this is the case, but just try to make a generalization that could be drawn from our data. In this case, since more married men are living at the age of 65, what we could infer is that being married may be associated with a longer life for men.